Alright everyone, in this video we're going to take a look at sprite animation. What we're going to do is build a very simple class that is going to allow us to read sprite sheet information, divide it up into individual tiles, and show those tiles as an animation.
Now we're going to kick off with this first video here where you're going to do just a little bit of whiteboarding first before we jump over into Visual Studio and start coding the class together.
Exactly. I want to explain the methodology that's going to be used to read the sprite sheet information. We're going to use some basic math to divide up the tiles into a sequential series of pictures that can be shown frame by frame as an animation.
Sounds great. Now you keep saying this sprite sheet. Can you show me what you're talking about?
Right, I have an example of that sprite sheet right here. This tile sheet PNG file contains about 30 tiles. As we can see here, I even had the image generation program number these, starting with 0, and you can see the last one down in this far corner ends at 28. That would give us 29 tiles if we were counting from 1, and then a blank one. I have purposely come up with a 29 frame animation so that we make sure that our sprite class can deal with odd frames.
Okay.
So as you can see here, this last frame is blue, and therefore would not be usable in the final. We simply want to omit it.
It would be very noticeable if it was injected into the sequence.
Exactly.
Was that blue?
Exactly. That's why I've left it very bright so that until we address this problem, we can see that there's an obvious problem.
Okay.
Also, take note of the way that the numbering is working here. If we start in the upper left-hand corner of the sprite sheet, we're starting at frame 0. Then we're advancing as we go to the right. So we have frame 0, followed by frame 1. Then frame 2, frame 3, and frame 4. Then from here we wrap back around to the left side of the image to continue with 5, 6, 7, and so on.
Cool.
And this is very important because it allows us to squash a lot of frames onto a square-style image. A more simplistic route would be to have the texture very narrow and very wide, where 0 through the right-hand side of the screen is the end of the animation. The problem with this is it doesn't make good use of the texture memory available on a graphics card. On a video card, you will very often not be able to make an infinitely wide texture but very narrow. If you use both the height and width from a texture, you can fit a lot more information onto a graphics card.
Gotcha.
So that's why we want to group everything into a square-ish rectangular shape.
Okay.
Now, what I want to do is switch over to the whiteboard for a few minutes and give a description of how one can cycle through these squarely laid out tiles using some simple division.
Okay.
So let's load up Photoshop, and I'm going to redraw this grid, though I'm going to draw it a little bit more simplistically. I'm going to draw a very simple 3x3 grid that we can number and then trace through.
Okay. And so, since you've done very little whiteboarding, I can make fun of you as you're drawing, right?
Sounds good. So we'll probably spend the next half of this video drawing a small box. So I'm going to make good use of my friend the Shift key, and we'll draw out what will probably end up being a kind of lopsided and off-angled box.
That's not bad so far. Good as
they say in most math books, this drawing is not to scale. But good enough. We can see that this is relatively square in shape. Now I am going to subdivide it into individual tiles. So I'll have one line and then a second line, because my goal here is a 3x3 grid.
And we'll just all pretend that these are equal in size.
Exactly. I will undo just that one. That's a little bit too narrow.
Down low, lower? Right
Lower.
there.
Excellent. Advice from the master of whiteboarding.
Up a little? Good enough. All right.
All right, so we'll pretend this is a grid. Same concept as the other one, just with fewer tiles.
Okay.
Now let me number these the same way that our example graphic was. Starting in the top left tile, we'll label this tile, tile 0. Moving to the right, we'll have this as tile 1, tile 2, 3, 4, 5, 6, 7, and 8. So a total of 9 tiles with the index starting at 0. So this is how the numbering can be viewed for the tile sheet.
Okay.
Now, let's take a look at another piece of information that we'll use when reading this. The driving force behind our animation system is going to be a frame index, a simple variable starting at 0 that continues to the maximum number of frames. If we had a num frames of 9 but 0 based, we would be looking at that guy. So what we're actually looking for is a number sequence that goes from 0 to 8, or a number of tiles minus 1.
Okay.
And let me take a few of those numbers back off the screen to keep the whiteboard clean. So what we'll be looking at is we'll be looking at a variable, let's call it f here. This will be our frame variable when we begin assembling the class. So f could be equal to, for this grid, f could be equal to anything from 0, 1, 2, 3, 4, so on and so on, up to the number 8.
Okay.
So then the number of f corresponds to the number of the tile that we have in the sprite sheet. And this is, of course, very easy to accomplish because once we get to 8, we could just modulus by 8. As a matter of fact, I'm not even sure why I put the number 8 up there. What will 0 through... Oh, yeah,
because you want 9.
I keep getting tripped up between 8 and 9. We're going... Because I keep thinking... once again, I keep thinking one less than one less than that. So by the end of the video, we should probably be looking at 3.
We've got 2 tiles.
But nonetheless, looking at 8, the idea, what I was looking for was if we always take this frame number and modulus it against 9, or the frame count at the end, that means if we add on to this 1, we get the number 9, we modulus that by 8, then we'll end up with, 0? Is that right? No, 8 modulus 8. The idea is that it'll repeat. We'll have... But I mean, so I won't go too deep into the explanation of modulus because at this point we should have used it for things in the past.
Right.
It's simple concepts that would allow us to get to 8 and then wrap back around to 0.
Right.
That's what I was going for.
So mod 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 will, of course, go into 9 one time with nothing left over, so we start back at 0.
See, there you go. You got it.
That's a quick review.
But now, while that is helpful in that we have a repeating sequence, it still doesn't help us translate into 2D coordinates necessary for finding tiles.
Very good point.
We need to find some way of mapping this sequential series of numbers into XY values that are useful for grabbing tiles. Because the core idea behind this this sheet here is that when we make a call to sprite batch, we have a source rectangle parameter that can be fed to it. That allows us to extract part of a source texture, omitting the rest of the texture. That means if we fed in the proper coordinates to find this rectangle, we could look at only cell or tile 0 out of the whole sheet.
So our goal is to come up with some sort of simple formula that's going to allow us to easily grab any, what you're calling tiles out of this
Exactly.
sheet.
More specifically, it's meant to translate that series of numbers.
That is an arrow, ladies and gentlemen.
That way. But that series of numbers into a specific tile based on which number you have selected.
Awesome. So obviously when you're creating one of these tile sheets, you're going to make sure that your animation is sequential then on the sheet itself.
Exactly, just like we had seen back in the graphic. As a matter of fact, I can pull it up real quick. Make sure that it follows the rule, continuing graphic by graphic and then wrapping back around. Though the wrapping back around brings up another interesting point and something we need to have locked down in the specification before we continue with code. Exactly how do we transverse the sheet? Let me pull a few more things off the sprite sheet. The idea here is that we start in tile 0, so which is easy enough because at the top left corner of the screen that is going to be 0 by 0, so not much work is required to find that guy. But the idea is we start in this tile, tile 0, and then to advance that would be if we were at frame 0, we start at tile 0.
Mm-hmm.
If we advance to frame 1, well...
No, that's good.
Okay, I was going to take off the that guy. I'll probably stop drawing arrows here in a minute anyway. But that would mean advancing to frame 1 would mean advancing into this tile.
Okay.
If we advance to frame 2, we'd advance into this tile. Again, all very simple since this entire thing has been in that direction.
Mm-hmm.
But what happens when we go past 2? Well, now we need to wrap around. That means to continue the sequence, we need to come down here, draw a really wavy kind of squiggly line, but indicating that we will wrap around and continue at tile 3.
Okay.
From tile 3, we'll continue to tile 4. 4 to 5, and then once again we've hit the right edge of the texture sheet, so we'll come back down again, and we'll wrap back around to 6, from 6 to 7, and from 7 to 8. Once we hit 8, that's the end of the sprite sequence, so we need to go all the way back around and up and plug back into frame 0.
Okay.
And that makes a continuous sequence of animation. If we view these tiles one by one, then we'll have a sequence of sprite animated frames. So that is the goal, to come up with this kind of navigation that will allow us to go from frame 0 to frame 8 with the proper repeats.
Okay.
And we have to do all of that having only this sequence given by f. And that is the current frame that we're on. So let me look around for a minute and find a nice open area of space to start explaining this.
Yeah, the bottom looks pretty good.
Let's begin with the very top row looking at x. How do we find, well, the first few are easy enough. If we just took the frame that we're on and we multiplied it, multiplied it by the number of tiles that we have in X. So that means we're going to need a few more variables here. Let me make another variable. Let's define a variable real quick. That's called, deciding I don't want to divide this up. I'll have this variable be called TLS capital X. This stands for tiles X. This counts how many tiles we have across the top. So 0, 1, 2. So how many is that? That's 1, 2, 3. So tiles X is going to be equal to 3 for this demonstration.
Okay.
And then another variable that we're going to have is TLS Y. And tiles Y is going to count how many tiles up and down. So 1, 2, and 3. That means tiles Y is going to be equal to 3 for this example. And these will be useful because we need to know what is the point at which we wrap back around. Here it'll be 3. Once tiles X equals 3, then we wrap back around. So I'm going to start plugging in some of the equation that makes this work. What we want to find is 2 X and Y values that can be used to find these sprite sheets. Though I'm going to do one more simplification before I write all this out. Let's instead imagine this entire grid is a grid of points now. So I could redraw this as a series of 9 points starting at 0 by 0 on the top left and ending at 3 by 3 on the bottom right. This simplifies the calculation so we can add in height and width later. But let me take all that out because I'm going to use this space for writing. So the first value we're looking for is an X and Y coordinate within that grid of points. So let's make our variable X. And we need to find that. So what we'll do to find X is we'll take our current frame number and we'll modulus it by tiles X. So TLS X, which in this case
since that's
is equal to 3. So it'll be framed modulus 3.
It's just going to set us up a repeating pattern of 0, 1, 2, 0, 1, 2.
Exactly. And I can actually draw that pattern. So if we want to find equals, what is the answer for each of those? Well, if we look at this frame by frame, that means we'll have a TLS X value of, for frame 0, we'll have 0. For frame 1, we'll have 1. 2, we'll have 2. Then 3 will begin at 0 again. 4 will be 1. 5 will be 2. 6 will begin again at 0, 1, and 2. So there is our repeating pattern, which means we find this tile, this tile, this tile, and then we repeat and do this tile, this tile, this tile. But we need to start advancing down so we get the next series of tiles. So that means we need to come up with a Y value to pick a tile up and down. So we'll make a Y variable. And then we need to have this value based on frame. And we need to, this time, divide. We need to use integer division to find what our Y value needs to be. So frame divided by 3. So again, this is going to be TLS X again, not Y. This is the easiest point of the whole equation to mess up on, because you immediately think, all right, we're moving down, so that must be Y, right? No, that is incorrect. What we actually need to do is to watch X, because we're moving this way to the right in X, and then once it is greater than the width here, so once we're greater than, if you're counting one base, once we're greater than 3, then we wrap back around. So it is actually X that is driving the Y position, as interesting as that may be. So let me see how many things I can undo back out here to make this.
And that's it.
And that is the end of the undo. So we bring out the great and mighty eraser. So let's take F divided by 3. Now what's important is that both of these guys here are integer types, because otherwise we're going to get a floating point decimal after the end of the division. If they are both integers, we'll do integer division on these guys, meaning that the remainder is simply dropped. Mm-hmm. And that's the key that makes all of this work. So integer division of the current frame divided by 3 equals what on the timeline? Let's go scroll all the way back up and take a look at the timeline. So here at the top, TLS Y for frame 0. 0 divided by 0 is going to be Well, technically it should be division by 0, but I think we'll get an undefined result. We might need to do a check on that. I would have to see the actual code to make sure. But the result we should get is for a frame of 0, we should get tiles or TLS y of 0. For 1, 3 divided by 1 without a remainder is still 0. 3 divided by 2, truncated, is still 0. 3 divided by 3, so looking at this guy now, frame 3, 3 divided by 3 is going to be 1. Divided by 4 without a remainder is still going to be 1. Divided by 5 without a remainder is still going to be 1. Divided by 6 is going to be 2. Without a remainder, still 2. And without a remainder, still 2. So that means as we're going down this grid here, we have the value 0 for that guy, 1, and then 2.
Right.
So that sets our x and y.
And you can see the y number actually repeating, 0, 0, 0. Those 3 times allowing us to hit 3 different boxes on the very first
Exactly.
row.
That means
row
y
1.
stays put for 3 values.
Then row 2.
Stays put for 3 more values.
And then finally row 3.
And stays put for 3 more values.
Once again, because you're dividing by the number of columns we've got.
Exactly. So, one last thing we need to do to these values before we use them, since now we'll get values like 0, 0 through 3, 3.
Mm-hmm.
That still doesn't account for the actual width and height of the texture. That means we need to know tile width and tile height. So before we use these, let me erase this a little bit more, we need to take this result and multiply it by the width and height of the given tile. So we need to take this guy and multiply it by a variable, I'm going to call it TW, tile width.
Okay.
And then our y value will have to be multiplied by tile height. And this time we are dealing with height, not x as here.
Right.
And once we do that, that way we'll have this actual point. So let's figure this out one more time. This time,
so we'll just pick some place in it and then pump the numbers through.
Exactly. If we were looking for this point on the actual tile sheet, well, that should resolve to 0. If we're at frame 0, 0 times, let's actually look at this. So 0 modulus 3 should be 0. 0 times width, let's make width and height equal to, right here, so this guy is 64. So width will be 64.
Okay.
And not negative 64 like it looks like there. So taking 0 modulus, or looking at here, so 0 modulus 3 should be 0 times 64 is 0.
Mm-hmm.
1 modulus 3 should be 1 times 64 would be 64. 3 modulus, or let's see, 2, 0, 1, 2 modulus 3 should be 2. 2 times 64 is 128. So that means we look at 128 here. And for this guy we start at 64. And for this guy we start at 128.
You want to make that first one 0?
Oh, whoops. Wow.
That's okay.
That's some interesting brain mapping there. But yeah, you're exactly correct.
Should have seen my Spock impression there when you wrote 128 and my eyebrow went up.
So a little bit jumbled on the whiteboard, but...
So yeah, it's just showing you that as you pump those first 3 frame numbers into there, first of all, we're going to grab the upper left-hand corner of 0, then we're going to grab the upper left-hand corner of the tile sheet at pixel 64, which will give us the start of the second tile, and then 128, which will give us the start of the third tile.
Exactly, and then that sequence repeats over, as we had seen by the mapping of TLSX here, 0, 1, 2, then 0, 1, 2 again, and then 0, 1, 2 again.
So it's going to back us back up to the beginning, but when we account for y, that's going to end up pushing us down onto the second row.
Right, when we start accounting for y, we go down here. We're multiplying by height, so we get all the way down to this level, then we get all the way down to this level, and then we end up at the very end.
Exactly. So in the end, the formula is actually quite simple. It's just x equals frame modulus by tile x, you said?
That would be TLSX. We'll probably call that variable tiles x when we get into the actual class.
Times the tile width, and then, of course, y is going to be frames divided by, again, tiles x multiplied by the tile height.
Exactly.
And that's going to pull out the exact coordinate that you need to be at. And then we know exactly how much to sample because we know that we got this point. Because in the end, correct me if I'm wrong here, but I'll just reach over here and grab this. They just want to draw. That's all it is. So these two guys are just going to give us a point, but then we know how far out we need to go over and off. So then we know the area that we need to sample.
Exactly.
Cool.
So with that, that's all I wanted to cover in the planning phase for the tile sheet operation.
Okay.
If there's anything else you want to add to...
No. So in the next video, we're going to go ahead and write a class that actually does this?
Yep. Next video, we'll pick up and write this as a class.
Fantastic. All right, well, that's going to wrap up this video. Thanks a lot.